Hello, scholars. Today we're going to look at comparing fractions. So over here we have a couple of different steps that we're going to be using in order to compare fractions. The first thing we need to do is actually read the fractions and interpret using the different vocabulary. The numerator being the parts that we have, and the denominator being how many parts are in a whole. After we read the fraction and understand the different pieces of the fraction, we're going to look at the denominator first to see if they have a common denominator. And if they don't, then we're going to move on to step 3, and we're going to look and see if they have a common numerator. So let's look at one example. So let's say we are comparing 4/8 to 3/8. So our first step is read the fractions. Let me put a little circle here for the symbol. We have 4/8 and we're comparing it to 3/8. So then the next step is we need to look at the denominator. So here we have 1/8 and 1/8. So that means they have a common denominator because that means the denominator is the same. When they have a common denominator, that means the parts are the same size. So if I was to draw 4/8, 1, 2, 3, 4, and 3/8, both fractions have the same size parts. I can also show that with fraction bars. Here's 4/8 and 3/8. So now I can compare, now that I have my different models and using the fraction bars, I can see that 1/8, since they have a common denominator, they are the same size part. So now what we need to do is look at the numerator to see how many parts that we have. And we need to see which one do we have more parts. So in 4/8 we have 1, 2, 3, 4 shaded in, and 3/8 we only have 3 shaded in. So that means 4/8 is greater than 3/8. I know this because they have the same denominator of 1/8, which means the parts are the same size. So we look at the numerator to see which one has more parts. And 4/8 has more parts. Okay, let's look at another one. This time, let's compare 2/6 and 5/6. So again, our first step is to read the fractions. 2/6, and we're comparing it to 5/6. Next step is to see if they have a common denominator. So here we have 6ths, and here we have 6ths. So yes, they have a common denominator, which means the denominator is the same. So once this goes off in my head, I should be thinking, ding, 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 ding. I should have a little light bulb above my head. That means that they are the same size. So that means that since they are the same size, I can look at the numerators to see which one has more. So this one is 2/6, so that means we only have 2 parts. So in this one we have 2 parts, and in this one we have 5 parts. So that means 5/6 is greater than 2/6, or I would read this as 2/6 is less than 5/6. And I can always double check my answer just in case and draw a shape model. I'm going to divide it in thirds and then in half. Here we have 2 shaded in and 5/6. Make sure I have the same size. 1, 2, 3, 4, 5. So I was correct. Ooh, I'm sorry, you couldn't see that. So 2 parts or 5 parts, that means this one is the same. All right, let's look at 2 more. So for this one, why don't we look at 2/4, and we're going to compare it to 2/6. So I'm going to go through my steps again. Read the fractions, 2/4, and we're comparing it to 2/6. Next, I'm going to see if they have a common denominator. So this denominator is 4. However, this denominator is 6. So no, they don't have a common denominator. So I'm going to move on and see if they have a common numerator. 2 and 2. So they do have a common numerator. So this means that they both have the same number of parts. So in both of them, in both pizzas, if we were saying these were pizzas, they both have 2 slices of pizza. So this would be a great way of thinking. Let's say Miss Hickson ate 2/4 of a pizza and Miss Mirth ate 2/6 of a pizza, and we want to see who ate more pizza. We both ate 2 pieces, but that doesn't mean we had the same amount of pizza. So let's start with drawing our shape model. Two-fourths. And I need to make sure my boxes are the same size. We had the same size pizza. And 2/6. So what I noticed with my shape model is that even though we both had 2 pieces of pizza, these parts are bigger. So the pieces that Miss Hickson ate are bigger than the pieces that Miss Mirth ate. And we can see that with our fraction bars as well. So here are the 4ths and 6ths. So the 4ths are bigger pieces than the 6ths. So my denominator, even though my denominator is a bigger number of 4, my pieces are actually smaller. Because I know that as the denominator gets bigger, so here's halves, and then they keep getting smaller as we go. Oh, sorry, I'm having a hard time focusing. There we go. As it goes through, each parts, since we're sharing it with more people or breaking them into more pieces, the pieces are getting smaller. So therefore, I know, 2/4 is greater than 2/6 because 4ths are bigger than 6ths. So they have the same number of parts on the top for the numerator, but the pieces are different sizes, and 4ths are bigger than 6ths. All right, let's look at another one. Let's do 3/5 and 3/10. So first step is to read the fractions. 3/5, comparing it to 3/10. And next we're going to look at the denominator to see if they have a common denominator. So here we have 5ths, but over here we have 10ths. So now they're not common denominators, so I can't compare them that way. So next step is to see if they have common numerators. 3 and 3. So yes, they have a common numerator. And again, just like I had a little light bulb go off over here, I should also be thinking, ding, 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 ding. They have a common numerator. So that means that they have the same number of parts, so I need to look at the denominators. And I'm really comparing fifths to tenths. What is bigger, a fifth or a tenth? So I know that as I keep breaking the whole into more pieces, they're getting smaller and smaller. So I know that fifths are bigger than tenths. So 3/5 is greater than 3/10. And I can prove my answer by drawing a shape model. Fifths, 1, 2, 3, 4, 5, and I have 3 shaded in. And I'm comparing it to 3/10. 1, 2, 3, 4, and then I divide it in half. So now I can even see that these are much bigger sizes than these. So here I only have 3. So yes, I proved my answer that 3/5 is bigger than 3/10, and I know this because fifths are bigger than tenths, and they both have 3 parts. So the 3/5, since these are bigger pieces, is bigger than 3/10.